What's up everyone, Patrick here, welcome back. Moving on to the next question. We have to take this expression here, we have to simplify it, and we also have to state restrictions. And the restrictions, notice we can actually get a couple of them from this initial format. So notice that x can't be 0 for sure because we have this 4 over x here and we have the 2 over x. So we can't be dividing by 0. That would make the whole thing undefined. So just from these two expressions we can tell x can't be 0. So that's definitely one of the restrictions. We can also get another restriction from this whole denominator. Right? Basically, there's no denominator that could be 0. So notice that the x can't be 0, but notice that this whole bracket is a denominator as well, which means that 3 minus 2 over x can't be 0 either. And we could isolate for the x here. We could bring the 2 over x over. We could cross multiply. You just treat this like an equation, but it's an inequality here. But the same rules can apply. And then to isolate for this x here, we could just divide both sides by 3. So x can't be 2 over 3. So that's the other restriction. And you could test it. If we took 2 over 3, plugged it in for this x value, we'd end up having, now 2 divided by 2 over 3 is like 2 over 1 divided by 2 over 3, which is like 2 over 1 times 3 over 2. The 2's cancel out, and we end up with 3 over here. 3 minus 3 is 0, and you can't be dividing by 0. Right? So it makes sense that that's another restriction. And then from here, that's pretty much all the restrictions that we can get. Sometimes when you're simplifying, you could run into situations where you can get more restrictions, but in this question, those are going to be the only two. But as we simplify, we can further check, and I'll mention whether or how these restrictions relate to the simplification, the versions that we get or the formats that we get when we simplify. Right, so we're good with the restrictions. Let me just erase this in case I need more room. So x can't be 0, x can't be 2 over 3. So to simplify this now, notice that we're taking expressions. We're taking this expression, dividing it by this expression, and then we're subtracting. So what I'm going to do is I'm actually first going to make sure that these two brackets here, they're one fraction, or they're one term. So then we can divide them easier. So the 3, that's like 3 over 1 plus 4 over x. Got to get a common denominator here. Multiply this by x, multiply that by x. So 3x plus 4 over x. Right? This bracket is the same as that. So this would basically be 3x plus 4 over x. Divided by, same thing over here, we're going to take the 3 minus 2 over x, this is like over 1, multiply this by x, multiply this by x. So we'll have 3x minus 2 over x. So this bracket and that expression are the same. So this would be 3x minus 2 over x, and then we're still subtracting this 5 over here. So to rewrite this, in maybe a nicer form, we can say 3x plus 4 over x divided by 3x minus 2 over x, and then we got minus 5. Now we got to do the BEDMAS, right? Be careful, we got to do the division first before the subtraction. And notice that now that it's in this format, we can compare the restrictions. So notice x can't be 0. These two denominators can't be 0, which is what we got. And then notice because we're dividing by a rational expression, when we're dividing by a rational expression, we also get the restrictions from the numerator. So notice that 3x minus 2 can't be 0, because that would make this whole bracket 0, and you can't divide by 0. 3x plus 4 can be 0. This could be 0, because you could take 0 divided by a number, but you can't take a number and divide it by 0. So the 3x minus 2 can't be 0, which means x can't be 2 over 3, which is what we got before from this initial format. Right, so I thought I would mention that. So we got all the restrictions. Let's simplify. So this would be 3x plus 4 over x. and we're dividing by this. So dividing by this means we could flip it. And then we're going to be subtracting the 5. So notice these x's cancel out. We end up with 3x plus 4 over 3x minus 2. Then we're subtracting 5. And now we can subtract these. Now we can simplify these, put them into one expression. So this 5, it's like over 1. So to get a common denominator here, multiply this by 3x minus 2, multiply this by 3x minus 2. So we would end up with 3x plus 4 minus 5 times 3x minus 2, and that's going to be all over 3x minus 2 like that. And now we could just simplify the numerator. So that would be 3x plus 4 minus 15x plus 10 all over 3x minus 2. Simplify this, so that would be negative 12x plus 14 over 3x minus 2. And then you always want to see whether you could further simplify. You always want to factor the remaining numerator. So notice from the numerator we could take out a negative 2, and that would be 6x minus 7 all over 3x minus 2. The reason why you want to do this last step is sometimes this and this can cancel out further, but in this case it's a different factor, so it's not going to cancel out, and so this ends up being the final answer. Right, so that's the final answer. Those are the restrictions, and if it's a multiple choice question, it could also maybe be in this format where that numerator isn't factored, but you always want to factor the numerator to see whether you could further simplify. In this case it doesn't, so either one of these is the final answer. Those are the two restrictions.